One year, a mango tree will be so weighed down with fruit its branches nearly touch the ground. The very next year, almost nothing. Same soil, same weather, same tree. Growers call this frustrating cycle alternate bearing. When a tree produces a massive crop, it often takes the following year off, eroding an orchard's predictable yield and its profit margins. The problem hits sought-after commercial varieties across South Asia particularly hard, with cultivars like Langra and Alfonso sometimes losing up to half their expected production every other year. It is easy to blame a bad season on unexpected heat, a lack of rain, or just the unpredictable nature of farming. But the truth is more mechanical. The tree is simply exhausted. It has run out of the biological resources necessary to create another harvest. To stabilize production, professional orchards manage the tree with a strict, measurable energy budget. Mango trees evolved over millions of years with a focus on survival. They are indifferent to human demands for consistent commercial yields. In this anatomical diagram, producing a heavy on-year harvest drains the tree's stored carbohydrates and soil nutrients. Post-harvest, it lacks the energy to push out healthy new shoots. Floral buds fail, forcing a barren recovery period. The first major intervention growers use to manipulate this cycle happens immediately after the fruit is picked: pruning. By cutting away dead, weak, and overcrowded branches, growers stop the tree from wasting resources. This shock forces the remaining energy straight into generating fresh, highly efficient foliage. Those new, mature terminal shoots are the specific locations where mango flowers emerge. Without them, future harvests are biologically impossible. Pruning redirects the tree's limited budget away from vegetative clutter and directly into next year's reproduction. That energy budget also extends below ground, where the tree makes constant withdrawals from the soil's chemical reserves. A massive harvest strips nitrogen, potassium, and vital micronutrients like zinc and boron. Growers have to precisely time their fertilizer applications to replenish those elements before post-harvest stress sets in. Irrigation requires the same strict balance. Overwatering causes useless leafy growth, while excessive drought during fruit development weakens the tree's structural health. Keeping the budget intact also requires a counterintuitive practice: fruit thinning. This split screen illustrates the math. On the left, keeping every fruit drains the tree to exhaustion. On the right, removing young fruit early conserves energy. The remaining mangoes grow larger, holding internal reserves to guarantee strong flowering next spring. Protecting the orchard from mealybugs and powdery mildew is about defending the biological machinery that produces the harvest, rather than just shielding the fruit. Healthy leaves operate as the tree's solar panels. Every insect bite or fungal spot reduces the canopy's ability to photosynthesize, cutting off the power supply needed to rebuild those internal stores. Fertilizer, water, thinning, and pest control act together as a unified defense system. They plug the leaks and prevent the tree from bankrupting itself. No single chemical spray or isolated treatment eliminates alternate bearing on its own. Commercial success relies on the synchronized orchestration of these energy-regulating practices, from the moment harvest ends until the next blossoms appear. Successful orchards avoid pushing for the absolute maximum yield in a single season. Instead, the priority remains preventing botanical exhaustion. By managing biological energy over the span of decades, the boom and bust cycle finally breaks. The result is a balanced orchard, capable of delivering high-quality harvests year after predictable year.